So here we are back in Visual Studio. What we're going to do is add a new class to perform the processing of binary data. We're going to call this new class Binary File Processor. We'll just add that. We'll remove these usings, and we'll also convert this to a file scoped namespace file. As with the text file processor earlier, we'll add two properties, one for the input file path and one for the output file path, and we'll also add a constructor taking these paths as parameters. As with the text file processor, we'll also add a process method. We need to make use of this new class, so we'll come back to the file processor and we'll scroll down to the switch statement and we'll add a new case, this time for .data files. We'll go and create an instance of the binary file processor and then we'll go and call the process method. And if we build this, the build succeeds. What I'm going to do now is just head over to a PowerShell window, and we're currently in the PS data directory. What we're going to do here is use format-hex in PowerShell to give us a printout of the bytes in this file. So data4.data consists of 4 bytes. We can see the hexadecimal here for these, 05, 0F, FF, and 5E. So what we're going to do is we're going to add some code to the process method to read in the input data file, find the largest byte, and then write out the original bytes and write the largest byte in the file to the end of the file. So in this case, we would end up with 5 bytes in the output file. Let's head back to Visual Studio and we'll head back to the binary file processor. So the first thing we want to do is read all of the bytes from the data file into memory into this byte array called data. To do this, once again, we make use of the file class and we call the readAllBytes method. There's also an async version of this method. This method takes a single parameter specifying the input data file path. Now we've loaded the entire contents of the file into this byte array in memory, we want to find the largest byte. So we'll create a new variable of type byte called largest, and we'll make use of the max extension method from link to do this for us. Let's declare a new byte array to hold the contents of the output file, and we'll make this byte array one larger than the original number of bytes. What we'll do is copy the original bytes to the new data byte array, and then we'll set the final element in the new data byte array to the largest byte from the original file. So now we have the final byte array that we want to output to a file. We can call the writeAllBytes method on the file class. This method takes 2 parameters, the first of which is the output file path, and the second is the array of bytes that we want to write to the file. In this case, it's the new data byte array. If we wanted to, we could simplify this code by making use of the new array indexing features that were first introduced in C# 8. So instead of specifying newData.length -1 here, we can refactor this to effectively index the last element in the array. Let's build this to make sure there's no errors, and the build succeeds. So let's run this modified program now, and we'll go and copy data4.data, which is the binary file, into the input directory, and after a few moments the file will be processed. So that's processing complete. Let's hit enter to return to Visual Studio. And to check that the completed output file is correct, what we're going to do is just copy the file name here with this random GUID. Just copy that to the clipboard and come back to PowerShell. Once again, use format-hex, but this time for the path, we'll specify the completed file that we just processed. So the original data4.data file had 4 bytes here, but notice the complete file has 5 bytes, with the additional 5th byte being the largest byte from the input file, in this case FF.